Okay, we are looking at example 2 in lesson 7.2 called Systems of Linear Equations with Three Variables. This is found on page 749 and 750 of your textbook. Now, what we have to do here, if you see this particular problem, is we have three variables and we also have three equations. So if we look at here, there's lots of methods that we can do, or at least avenues we can take. Our initial goal is to reduce the three equations with three variables down to two equations that have two variables in them. So we need to decide up front which one we're going to choose to eliminate. In this particular case, we're going to choose to eliminate the z's. So if you'll notice, we're going to take equation 1 and equation 2, and we're going to try to eliminate the x's. Now, one of them is minus 4z, and the other one is 2z. So because they're opposites of each other, if I simply would multiply this bottom equation by 2 and not do anything to the top, notice that you get 5x minus 2y minus 4z equals 3. That's just the original one on the top. The second one, if we multiply everything by 2, ends up being 6x plus 6y plus 4z equals negative 6. This ends up, now you're going to add those equations together, and when you do, you're going to get 11x's. You're going to get plus 4y. Notice that your z's here are opposites of each other and therefore will eliminate each other, which is called the elimination method. And then 3 plus negative 6, of course, becomes negative 3. Now, that's equation number 1. Now, we proceed on by taking the second two equations together, the 3x plus 3y plus 2z equals negative 3, and the negative 2x plus 5y plus 3z equals 3. Now, in this particular one, we're going to get the 2z and the 3z to be opposites of each other. If I multiplied the top one by negative 3 and I multiply the bottom one by 2, you can see over here that one's going to become negative 6z, the other one's going to become positive 6z. So we're going to again eliminate the same variable, which in this case happens to be z's. Whatever you do in the first one, eliminating y's, you have to do in the second one. So this ends up, when we add those together, we end up with negative 13x plus 1y, because you have a negative 9 here and you have a 10z there, for a total of 1y, and then 9 plus 6 here equals 15. Now, once you come up with these two equations, they're listing those as equation 4 and equation 5. Now that we end up with two equations with only two variables in them, then we're going to start over as though we did back in section 7.1 of this particular chapter. What we're going to do at this point is we're going to just do basic elimination again. So if we have those two, which was equation 4 and 5 that we put together, this one, the easiest thing to eliminate would be to multiply the bottom one by negative 4, and we would end up, remember you have to do the whole equation that way, so you end up with 52x minus 4y equals negative 60. Now notice that we have a positive 4y and a negative 4y, so that when we add those together, we end up with 63x equals negative 63. So when you divide both sides by 63, of course, you're going to end up that x equals negative 1. So we have solved one of the equations. Now that we know what x is, we go back to one of our two original, which would be equation 4 and 5. We go back to one of those. If you look at this example, they chose example 5. And now that we know that x is equal to negative 1, we're going to substitute that back in. So it becomes negative 13 times negative 1 plus y equals 15. When we solve that, that becomes 13 plus y equals 15. And of course, if you subtract the 13 over to the other side, you're going to end up with y equals 2. Now we know 2 of the 3 examples, or 3 solutions. The third one, we have to go back to one of our 3 original equations, and we're going to substitute in the -1 for x, as you can see here and here. We're going to substitute the 2 in for the y, which you see here and here. And this time we're going to solve, of course, for the z. Now, they chose equation 2. That does not matter. You could have chosen equation 1 or 3. It really, really does not matter. It's going to come out the same in the end. So by substituting and using equation 2, we end up with this being 3, this being, this is -3 and this is 6. Together that makes 3 plus 2z equals -3. If I subtract this 3 right here over to this side, I end up with -6. So 2z equals -6. Divide both sides by 2, of course, and z ends up being a -3. So once we have the 3 answers, remember x was -1, y was 2, and z was -3. We write them as an ordered triple, which means we put those in parentheses, listing the x first, the y second, and the z third. And I know a little of this got cut off, but your answer would be -1, comma, 2, comma, -3. And that would be your solution. That is the x, the y, and the z value that would fulfill all 3 equations and make all 3 of them true at the same time. I hope this helps.